Okay, we have another one that's a fraction. F of x equals 3x minus 5 over 2x minus 3. We're still going to follow the same four-step procedure. Again, the first step always is you want to change the f of x into a y, so now we're done with that step. Step number 2, we need to switch the x and the y. Okay, so we switched that, and so all the x's now became y's, all the y's now became an x. You're done with step number 2. Step 3, you need to solve for y. So again, because there's two y's here, that involves a special process. If I make that x over 1, that means that I'm going to do some cross multiplying in order to bring that over. So I'm going to multiply these together, x times 2y minus 3. And then that's going to be equal to 1 times 3y minus 5. So now I have this as a result. You need to get all the y's on one side of the equation, so you need to free up the y that's in there. So I'm going to multiply this through first and get 2xy minus 3x. That's going to equal 3y minus 5. I need to do that step to free up the y. So now I need to get all the y's on one side of the equation. I'm going to bring this y across the equal sign. It's going to become negative, so I get that. This 3y, I want to move that across the equal sign, so I need to add that. So when I move it across, the negative turns into a positive, and I get 3x minus 5 there. Now I want to factor out a y in this step, so factoring out a y, you get 2x minus 3. And I'm doing that step again. I'm factoring out the y because now I have one of them, and I can just divide both sides by 2y minus 3 to get my answer. So if I divide this side and this side by 2x minus 3, so for step 4, I would have y equals, but I'm going to change that y into an inverse. So the inverse is equal to 3x minus 5 over 2x minus 3. So you might be thinking, well, wait a minute, did we make a mistake? Because we got exactly the same answer. My inverse was exactly the same as the original one. Was there a mistake done? Well, I hope not, because if there was a mistake, I could have just redone this video and then it would have been correct. So anyway, this is actually possible that that could happen. Now the reason why that is because if the original line that you have is already symmetric about the line y equal x, that means that if you find the inverse, then that one's automatically you're going to get the same exact answer. So in other words, if I were to draw this one, and we're going to be doing this in a later section when we talk about the rational functions, but if you were to graph that one, you would see that that original line automatically would be symmetric about the line y equal x. In other words, the line y equal x is that fold line. You can fold one over and it'll lay on top of itself. So whenever that happens, when the original one is already symmetric to that line, that means that when you find the inverse, you always will get the same thing as a result. You'll get itself for the inverse. So we didn't do anything wrong here. This is the correct inverse. This is just one of those rare cases where the inverse happens to be the same as the original one.